This is the first video for our microfluidic device Ansys walkthrough. We're going to be covering the geometry in the mesh in this video. There will be a second video that goes through the setup and the solver of the simulation. So we have my VMware system loaded up. I've gone ahead and opened Workbench. We're going to start up our Fluent simulation, geometry. We're going to set our property as 2D and go ahead and open up our design modeler. So for reference, we're going to be building a microfluidic device that has 3 inlets and 1 outlet. The 2 inlets will be injecting fluid of water. The other inlet will be injecting oil that will form oil droplets inside our microfluidic channel. Okay, so we have our design models open. Let's go ahead and look at the XY plane. And we're going to zoom in a fair amount so that we're going to build a device that has about a 0.25 millimeter cross section. And so in fact, we're going to go ahead and change our units to millimeters instead of meters. So 25 millimeters, you can see down here, that's roughly a scale bar here. So we're reasonably zoomed in. Okay, so we're going to create a number of rectangles and lines. We're going to set the dimensions for them and then trim out our particular device. So we're going to create a set of 3 rectangles. One is centered on the x-axis. One is going to cross that box. And then one is a longer rectangle, again centered on the x-axis. And finally, we're going to connect the 2 corners from here to here and from here to here. And so what's going to happen is through our left inlet here, we're going to be injecting our oil. From our top and bottom inlets, we're going to be injecting water. As the oil comes through, a droplet's going to pinch off in this region here and then pass down our channel. And so in fact, Professor Hedrovo does simulations that look like this, or does experiments that look like this, except for using water and air, and he produces water droplets. Okay, so we've created a rough sketch of the system, but now we have to settle in on some of the dimensions. Okay. So the dimensions, each width of these inlets is going to be 1/4 of a millimeter wide. So I guess this is quite large relative to what I wanted. So let's just make sure I've got my dimensions set. So yes, I want it to be 1/4 of a millimeter. So all of this is well oversized, so we have to be a little bit careful here that we don't lose track of things. So this is going to be 0.25 wide, and so you can see just how important it is to zoom in. So in fact, before we try to create all this stuff again, why don't we go ahead and just restart. So we'll go ahead and delete this sketch, start over, and we want to zoom in even more than the 25 millimeters to where we're seeing down to about 1 millimeter in length scale. So now you can see, okay, this is 1 millimeter. That means our channel width is going to be with this. The overall thing is going to be about 3 millimeters long. So we'll zoom in a little bit more and go ahead and try again. All right, so our sketch, we're going to have a rectangle, like so. Another rectangle like this. Third rectangle over here. And then some lines connecting our channel. Okay, so let's go ahead and do some of the dimensioning. So again, our channel width, our inlet width is going to be 0.25. So again, not quite the right size, but that's okay. The overall length of this rectangle, we're going to set that as 3 times that length, so that's going to be 0.75 or 0.75. And we're going to want it centered, so the distance from the x-axis to the inlet will be half of 0.75, which would be 0.375. Okay. When we go ahead and set this dimension next, so this is also the length of our horizontal rectangle is also going to have a distance of 0.75, which nicely pushes everything out. And our height is going to be 0.25 with a distance to the x-axis of half of that, which would be 0.125. Okay. Our distance to the vertical rectangle is going to be 0.25. So now we can sort of nicely see our plus sign showing up here. Okay, so now let's deal with this channel. So we have the distance. The horizontal distance from this point to this point will also be 0.25. So I've clicked on the points, and we'll see why in a little bit. And the overall height of our outlet region is going to be 0.5. So each of these outlet regions is going to have a distance of 0.25 to the x-axis. And then finally, we're going to set the length of our outlet channel to be 3 millimeters long. Okay, so we can reposition. And so this is our final geometry shape. Now, we've used the rectangles to sort of simplify the drawing of this, but actually we have a number of extra lines that we don't need. In particular, these lines here, where we need to have fluid moving through those barriers, we need to go ahead and get rid of those. So we're going to use the modify function. So right above where we set our dimensions, there are a number of modifications that we can make in here. And so the one we're going to be using is trim, which allows us to eliminate some of the edges in our domain. So we can click on a particular edge, and be careful where you click on it. The segment that you're clicking on is what will be deleted. So I've got my cursor selected in the middle of this, and you can see I've removed that edge. Same thing here. Notice that it does stop at the x-axis, so you're going to have to click on that region twice. So we've eliminated everything so far. Notice that everything is still blue, which means everything's properly defined dimensionally. Okay, still looking good. And then finally, okay, so now we do have a slight issue. Because we've deleted some of our lines, we've lost some of the constraints. You could go back through and redefine the dimension. I think the only one we have to do is constrain this distance horizontally. And I think the other one we have to do is constrain this distance vertically. I guess not. So we'll undo that one. What I would say is, so we can, let's see. The other one we have to define is this distance here. And that takes care of it. So we've gone ahead and added dimensions. Notice we didn't plug in any values for those dimensions. We didn't actually change the sketch at all. What I would say is you don't necessarily have to have your sketch fully defined, but you do take the risk that there's potential ambiguities when someone else is trying to implement your system. So I'll obviously be posting a PDF with all of the dimensions included here. But at this point, we're done with our sketch. So we can go in our modeling, click on our sketch 2, since we had to delete our sketch 1, concept, surface from sketches, apply for our base sketch, and then we can generate and produces our microfluidic channel. Okay, let's go ahead and save our project. Okay, project is saved. We can close our design modeler and go ahead and open up our mesh. So in our mesh, we're going to go ahead and do a couple things. We're going to define some of the basic properties of the mesh. We're going to include an inflation, which allows us to have a nice high-resolution boundary layer along some of our walls. And then we're going to, of course, name our boundaries so we can use them in our solver setup. Okay, so it's loading up our mesh now, or loading up our geometry now. And just out of curiosity, we can take a look at our base mesh, which is obviously a pretty low resolution. Okay. So we're going to make a modification to the mesh property. So if you click on mesh, you'll notice there are details of the mesh down here. You can click on some of these values, particularly ones that say default, and you can update these values to something that you want. So if we want to set our standard mesh size to something like 25 micrometers, we can type in 25 E-6, and that's going to update the base element size. And so now you can see again, we have an obsolete mesh, so we can go ahead and generate our mesh again. And now, just the default mesh comes through at a much higher resolution, which looks good. Okay. Next, we're going to go ahead and add the inflation. So as I mentioned, we have a boundary layer. We have a high viscosity fluid. So we have a boundary layer that's going to occur, although this is moving at a really low Reynolds number. So the boundary layer is not going to be overly important for this problem. But just because we don't want the bubbles to have too much of an issue, particularly where it's pinned to the boundary, we want to have a reasonably high resolution. So what we're going to do is we're going to go to Mesh, and then notice here is an option called Inflation. So Inflation applies a layer of boundary cells next to whatever designated wall you want. So the geometry or the surface that we have to select is our full domain. We apply this. And now it's up to us to select which boundaries we want to apply this to. So we're going to apply it to all of our boundaries that are not inlets or walls. So for reference, we have our oil inlet, our two water outlets up top and bottom, and then on our far right end, that's our outlet. So overall, we have 12 walls, and I'm going to just go ahead and scroll through and highlight them. So it's each of these 8 walls that form the plus sign, our 2 diagonal walls, our 2 long horizontal walls, and go ahead and apply. And so you see I've got 12 edges selected. And we're going to just simply increase the maximum layers from 2 to 5, and we'll keep the growth rate at 1.2 is fine. Okay, so with that, we're done with our inflation, and we can update our geometry. Okay, and so you can notice we've got a higher resolution set of cells on the edge, and so we can zoom in a little bit and see how we have a high resolution, very thin, long cells at the edge, sort of form nice square cells in the middle, and then go back to long, thin cells at the top and bottom of the boundary. And this goes throughout our geometry. So that's all we're going to do with our mesh. So just for reference, in the details, so again, select Mesh, Details of Mesh. You can scroll down and see Statistics, and this will give you some information. So the total number of nodes we have is 4,623. And the number of elements we have is 4,400 or so. So you want to make sure you have roughly these values when you perform your meshing. Okay, the final thing we want to do here is go ahead and name our boundaries. So we can go ahead and right-click on our inlet on the left. So we're going to do Create Name Selection. This is going to be our oil inlet. Our top and bottom cell or boundaries are going to be our water inlet. Our right boundary is going to be our outlet. And then the 12 walls where we've added an inflation will just simply be our walls. Okay. So we can see our set of name selections. So we have our inlet for oil. Top and bottom will be our water inlet, our oil outlet, and then our 12 walls. Okay, with that we can go ahead and save. And that concludes our geometry and meshing for the Microfluidics channel.